Hi students, welcome to the another session of our classification of elements, the periodic table. That today we are going to discuss about part 5, and in that part 5 we are going to talk about modern periodic table. Modern periodic table which is being proposed by H. George Moseley in 1913. Okay, 1913 he has proposed that table. What are the contributions of him to arrange that modern arrange the elements in the modern periodic table? That is the agenda of this session, and a huge vast syllabus where it cannot be completed in one video. There will be some continuous videos which will be having the continuity of this topic. So from part 5 to we have some continuity. The topic will be extended to some part 6 and part 7, like that it will go. Okay, so till now what we have discussed is the elements which were available till now. There is a need of arranging them in a proper order. The elements which were known at that time, there is a need of arranging them with a proper order. That's what main requirement. Why? In order to access them easily. To make it so, Dobrynin has proposed the law of triads, that is three elements as a group he has taken, and it was failed whenever it is coming to the last end of the list, that is not following the triads rule, so it is has been considered as failed. After that, Newlands has came into in the picture, and he has divided the elements into 8 as a group. 8 elements as a group. 8 elements. After 8th element, the pattern is getting repeated, and the horizontal rows is said as a group. Okay, every 8th element from a respective element is going to repeat the same properties. That's what was the proposal by the Newlands. And in the last sessions we were talking about Mendeleev, the Mendeleev periodic table with groups and subgroups and periods. What are the features? The group and subgroups and periods, and predicting the missing elements is the feature, and what is the correction of atomic weights, making it to sit in the respective appropriate group. That what we have discussed. And we have discussed about anomalous series, that is arranging them in an interchanging manner, even though it is not following the ascending order of the arrangement of atomic weights when it is been arranging of that elements in a table. This what all, and what are the limitations that what we have discussed in the last session. The continuity of the last session is in order to, as Mendeleev has contributed a very good information about, arranging the elements in a proper manner as a table. To honor him, go to page number 129. To honor him, do you know block we have? At the time when the Mendeleev introduced this periodic table, even electrons were not discovered. Okay, that is, even then the periodic table was able to provide a scientific base for the study of chemistry of elements. In honor of the 101th element was named Mendelevium. To honor, as the Mendeleev has contributed so much base idea, a very good base idea to have the difference of arranging the elements in a proper manner. In order to honor that scientist for providing a base construction of idea to have the arrangement of elements in a tabular form, to honor him, 101 element number 101 is given as Mendelevium. That is a small recap or review of the last sessions, whatever we have discussed. Now we are going to discuss about modern periodic table. Okay, listen carefully now onwards. Okay, modern periodic table, which is being proposed by H.J. Moseley. Okay, just a review of that tables once. If you go back and see, this was the arrangement. This table in page number 123 was the arrangement of three elements as a group, was given by Dobrynin, and 7 elements, every 7th element is repeating its properties. This table was given by the Newlands. Okay, this is the Mendeleev periodic table. Mendeleev periodic table is been arranged the elements in this pattern according to the arrangement of increasing order of the atomic weight. He himself modified this table and proposed, Mendeleev himself modifies this table. This is the old version table which has been printed in 1871. He himself modified and he gave the new form of a this is the modified periodic table. This is the modified periodic table, even though it has some merits and demerits. In order to overcome all the demerits which were there in this arrangement of the elements which is being proposed by the Mendeleev, okay, the H.J. Moseley, okay, H.J. Moseley contributed or changed his ideas based on some important points which are being suggested by the Mendeleev. Some features by adopting or taking the concern of some features from which are being suggested by the Mendeleev. Okay, Moseley has proposed this arrangement. This arrangement of elements is called as modern periodic table, which is now in existence. You can refer in page number 132. Okay, the modern periodic table, which is shown in this page number 132, shows the arrangement of elements in this manner. Okay, what makes the elements to be arranged in this manner? That's what we are going to discuss in detail. Okay, now onwards it is very important session. Try to focus much. If you have any doubts, you can have a query on Saturday. Just write it in your notes or somewhere and you can ask that query on Saturday when we meet. So H.J. Moseley, for example, whenever we are talking about Dobryner's, listen here, now onwards listen carefully all of you. Dobryner, whenever he was arranging the elements, he was focusing on atomic weights, considering in atomic weights, Dobryner's. And then again Newlands came into picture. Again he was dealing with the elements, arranging the elements according to the atomic weights. Again Mendeleev is being proposed the arrangement of elements based on the atomic weights. Okay, these three scientists proposed the arrangement of elements based on the atomic weights of increasing order of the atomic weights of elements. That is, they were much concerned or they were much focusing the arrangement of elements based on the atomic weight of the elements. Okay. Now, what happened is Moseley has changed his view. Moseley has changed his view to arrange the elements based on the atomic number. Instead of arranging the elements in the atomic weight form, okay, by considering the atomic weights, instead of arranging the elements in a proper in an order, he thought of taking the atomic numbers into the consideration. Moseley thought of taking the atomic numbers into consideration to have a proper arrangement, than a satisfactory arrangement of the elements than the Dobryner's and Newlands and Mendeleev's. Okay, what is that? How does he is able to concentrate on? Atomic weights? How his observation was? A small segment is there, that is reading and understanding session. That you have to go with the page number 130. A small reading and understanding session, which will help us to understand this even more better. That is what made Moseley to divert towards. What made Moseley to focus towards the atomic numbers instead of atomic weights. Okay, these all scientists were discussing the arrangement with the based on atomic weights. What made Moseley to divert or choose the atomic numbers of the elements to arrange them in a proper order? That's just a small reading and understanding session is we have available in page number 130. Second thing and discuss above, we have modern periodic table. H.J. Moseley in 1913 found that element emits a characteristic pattern of X-ray when subjected to the bombardment by high energy electron. Okay, that is, whenever the elements are bombarded to the high energy, they are going to emit when the element is bombarded to the high energy. Okay, when it is introduced to the high energy or the high electricity is passed through that element, it is going to release or emit X-rays. It's going to emit X-rays, and by analyzing that X-ray pattern, as it is going to emit, as the element is going to emit X-rays, that by observing that or analyzing that X-ray pattern, Moseley was able to count the number of positive charges in the atom of respective elements. By studying that X-ray, Moseley was able to count the number of positive charges, that is protons, which are present in the elements. Okay, studying the X-ray, keep in mind, very important. Okay, when an element is subjected to high energy, it is good. When the element is subjected to high energy, it is going to emit X-rays. By observing these X-rays, Moseley was able to count or calculate number of protons, that is positive charges. Okay, emit high energy. If they subjected to, the electron is subjected to high energy, it is going to emit X-ray. By observing or studying this X-ray, the Moseley is able to calculate or count the number. This is number of protons, that is number of positive charges. And already we know that in the 9th class we have read that the number of protons is the atomic number. Okay, the number of protons is equal to atomic number. So for example, if an element the atom of an element, some element consists of 6 protons, for example, it contains 6 protons. So what is the atomic number of that element, or that element is 6. Okay, if any atom of an element consisting of 17 protons, the atomic number of that respective element is 17. Okay, like that he is able to assign, depending on the X-ray which is emitted by the element, H.J. Moseley is able to count the number of electrons, or able to calculate the number of electrons. This number of electrons is helping him to assign some atomic number, for that element, and he was able to arrange the elements according to the atomic numbers. Okay, that is start of thinking. Now we start of thinking, arranging the elements in ascending order of. So what is the, as is able to, are able to understand, all of you, are as the Moseley is able to count, or is able to calculate, or is able to determine the atomic number by studying the X-rays which is emitted by the electron or atom of that element. He thought of arranging the elements instead of with the atomic weights. He chose the another way, arranging the elements in increasing order of atomic numbers. Now the atomic numbers concept is come into existence. Okay, that's what it is being given here. See, after knowing the atomic numbers, okay, before that we have respect to the number of positive charge protons in an atom of an element is called the atomic number of that element. That's what we have discussed. With this analysis, Moseley realized that the atomic number Z is more fundamental characteristic of an element than its atomic weight. Okay, Moseley realized that instead of choosing the atomic weight, atomic number will be more fundamental concept which is helpful for arranging the elements, was his thought. After knowing the atomic number of the element, it was recognized that a better way of arranging the elements in the periodic table is according to the increasing order of atomic numbers. Okay, Moseley realized that instead of arranging the elements based on the atomic weights, he thought of arranging the elements based on the atomic numbers. Okay, atomic number 1, atomic number 2, atomic number 3. Till now the three scientists were discussing the arrangement about atomic weights. Atomic weight of a carbon, atomic weight of an oxygen, hydrogen. Based on the atomic weights they were arranging. But Moseley thought of arranging the elements based on the atomic numbers. Keep in mind, this is the change that you have to note down. So we have, for example, tellurium. What does it, based on the atomic numbers, if he is able to arrange, suppose, what are the main things he can overcome? Okay, why that Mendeleev choose arrangement of elements according to the atomic numbers instead of atomic weights is because to eliminate all the limitations which were encountered by the remaining three scientists. See, according to the Mendeleev, one drawback is anomalous series. Anomalous series is that in tellurium, suppose tellurium with tellurium we have yesterday we have discussed about tellurium is with 127.6 atomic weight, that iodine I is 126.9 is the atomic weight, but is tellurium is coming first and whereas iodine is coming first, it was not correct. Okay, but whenever the Moseley has calculated his atomic numbers, the tellurium atomic number was 52 and the iodine's atomic number was 53. That is, there were 52 protons were available and 53 protons are available in iodine. So if he was arranging in the concern of the atomic numbers, it is following the satisfactory arrangement. Where if he was arranging with the atomic weights, it's not satisfying the increasing order arrangement, because smaller value should come first and the bigger value should be next. But here, if we go with atomic numbers, the bigger atomic weight is coming first and the smaller atomic coming next, where it is not the appropriate manner of arranging the elements based on the atomic weights. Okay, so in order to get rid of this anomalous series and to get rid of all different limitations which were there in the previous suggestions, the Moseley has concentrating on the atomic numbers instead of atomic weights. That's what is the example. See, for example, though the tellurium has more atomic weight. See, though the tellurium has more atomic weight than the iodine, that is, tellurium's atomic weight is 127.6. Iodine's atomic weight is 126.9. Though the tellurium has more atomic weight, then its atomic number is less by 1 unit compared to iodine. Even though it is having, even though the tellurium having the more atomic weight, but its number is 1 less than the iodine. Atomic weight is more, but atomic number is just 1 unit is less than the iodine. So if the concern of atomic weights, atomic numbers if we go, the tellurium will have the proper arrangement, right? Because tellurium has 1 less unit than the iodine. So according to the atomic numbers if we go, we can ignore this anomalous series. Okay, fine. Are you able to follow this? This atomic number concept force the periodic law to change. Okay, the concept of atomic numbers is changed in the periodic law. See, what is a periodic law? Okay, the law which is used for arranging the elements is considered as the periodic law. What is the changes in the periodic law that we will discuss? First, what was the periodic law which is being adopted or which is being followed by the Mendeleev? We will discuss. What is the periodic law? Mendeleev's periodic law will see. Then afterwards, what is the change made by the Moseley? We will understand. Then Moseley himself, again he modified his law to arrange the elements in this tabular form. What is that modified periodic law? Also that we will discuss. Okay. First we are going to discuss about the periodic law. Very important session, keep in mind. See, what is the periodic law which is being proposed by Mendeleev? First, that Mendeleev's periodic law. We know that Mendeleev's periodic law is stated as, what is the periodic law is going to state? The properties of elements are periodic function to their atomic weights. Okay, what is the periodic? That is Mendeleev's periodic law is going to state. What is the Mendeleev periodic law? Is the properties of elements or the periodic function functions of their atomic weights. This is the law. Okay, that is the arrangement of elements in an ascending order of the atomic weights is concern of the atomic weights. Based on the atomic weights concept, the properties of the elements were categorized by Mendeleev. The last session what we have discussed. Okay, now how the Moseley has been changed. See here, the periodic law. What happened is, see here, the periodic law is changed from atomic weight concept to atomic number concept, and known it called as modern periodic law. As the periodic law has changed, that we call as modern periodic law. We know that Mendeleev periodic law is stated as the properties of the elements are periodic function to their atomic weights. Now let us try to understand the modern periodic law. Okay. The Mendeleev periodic law is the properties of the elements or the periodic functions of their atomic weights. Based on the atomic weights, the arrangement was taken place by the Mendeleev periodic table. Now the modern periodic table, if I consider, that is modern periodic law. If I go with the modern periodic law, okay. Same. What is the properties of the elements are periodic function on their atomic numbers. Same. See, the property of elements are the periodic functions of their atomic that is the concept of atomic weights concern is being changed to atomic numbers to arrange the elements. Okay, that is instead of arranging the elements with the base with the help of the atomic weights of those elements, it has been changed to the periodic law has been changed to atomic numbers. That is Moseley was concerned about arranging the elements based on the atomic numbers. He is nowhere concerned about the atomic weights. He was focusing on the atomic numbers of the elements to arrange them in a increasing order. Okay. He himself, see, the modern periodic law states that the properties of the elements are the periodic function of their atomic numbers. Okay. But there is small concern here when we focus on the atomic numbers. Okay, see here we are talking about the atomic numbers are based on the number of protons. Atomic numbers are of an atom is based on the number of protons, but the number of protons is nowhere concerned about characterizing the atoms. The number of protons are nowhere concerned about the characterizing the various number of atoms. What does it mean? Okay, suppose, what does it mean? Actually, it is being given by the Dalton. Just a recap of that concept. Very important. Listen here. See, assume this part of my hand is an atom. This part of an atom as this part of my hand as other atom. See, scientists proposed that is Dalton. Actually, Dalton proposed that the number of the subatomic particles which are present in this atom, some subatomic particles are there, and the subatomic particles which are considered in this atom, both are same type of subatomic particles. That is electrons. The electrons which are present in this atom, Keep in mind, see, listen here all of you. The electrons which are present in this atom and the electrons which are present in this atom, properties wise are same. There are same type of electrons are present. Why there is a difference between the atoms of these two elements? Why there are two atoms? This is atom of one element. This is atom of one element. Why it is being made? Because the number of electrons are playing the key role. Keep in mind. Listen here. Okay. The number of electrons present in an atom. The number of electrons present in an atom is playing a key role in order to have the existence of different atoms. See, if the electrons are 3, suppose 3 electrons are present in this atom, this is one type of element. If the electrons are 4, this is one type of atom. If any atom consists of this is one type of element. If any atom of a substance consisting of 10 electrons, that is one more atom, one more type of electron. If an atom of some element is consisting of 12 electrons, that is one more. The electrons are of same type, but the number of electrons are making the change in the variation of different atoms. Fine? Did you understand, all of you? That is, the number of electrons which are present in the atoms are responsible for existing of different atoms, that is different elements. If one atom consists of two electrons, that is one type of atom. If another atom is consisting of 7 electrons, that is the atom of another element. That is, number of electrons are playing a key role. So, why this is being useful here? Let's try to understand. See, if I go with the concern of atomic number, that is based on the number of protons, and as the number of protons is not is playing any role in the existence of different elements, mostly thought of changing the concept of the atomic numbers, arrangement of that elements based on the atomic numbers. He himself modified the periodic law to, this is modified modern, very important, listen here. So modified modern periodic law. Why there is a need of modifying the periodic law? That's what I want to explain. Keep in mind. Okay? Instead of concerning, if he is able to concern about the atomic number, that is based on the number of protons, it's nowhere, number of protons is nowhere significance in order to categorize the elements. In order to categorize the elements, or in order to have the difference of the elements, number of protons are not playing any key role. So that's why, as the number of electrons are playing a key role, that's why we want to change its periodic law. Okay. See, based on the periodic law of the modern periodic table, it was given in this page number 132. It was the extension of that modern periodic table is the extension of the Mendeleev's periodic table. Okay, that Mendeleev periodic table is called as short form periodic table. This Mendeleev's periodic table is called as the short form of the periodic table, and the periodic table which is being given here, it is called in the page number 132 is referred as long form of the periodic table. Okay. It is a short, Mendeleev's periodic table is a short form periodic table. This modern periodic table is a long form. Based on the modern periodic law, the modern periodic table which is given in page number 132 is proposed. That based on the modern periodic law, it is being proposed. It is an extension of the original periodic table known as short form of the table. In the modern periodic table is called long form periodic table. Okay. Mendeleev's periodic table is called as short form. This modern periodic table is called as long form periodic table. It is given in figure 2. The atomic number of element is indicated not only the positive charges, the number of protons, that is the protons in the nucleus of the atom, but also the number of electrons in the neutral atom of that element. Okay, that means the number of atomic number is not only giving the number of protons, Okay, it internally giving the number of electrons also. See, atomic number gives the information about number of protons. Atomic number gives the information about number of protons. That means if we have 6 protons, 6 electrons should be there in order to maintain the neutrality of the atom. That already we have learned in 9th class. That is, how many number of protons are present, that many number of electrons will be present in the atom. Okay, 12 protons, 12 electrons will be present. 13 protons, 13 electrons will be present in this atom. Okay, to maintain the neutrality, to maintain the electric charge, neutral electric charge, that okay, to give the physical and chemical properties of an atom, of an element, depends not on the number of protons. See, that's what I want to tell. Okay, the physical and chemical properties of an atom is not depending on the number of protons. Number of protons are nowhere significant, not playing any role to have the differentiation of the physical and chemical properties of different elements. Where we can have, but the number of electrons and their arrangement, the number of electrons and their arrangement in the atom is playing a key role to have the existence of different elements in chemistry. There are 118 elements are present in chemistry. How these 118 elements are being categorized? Based on the number of electrons and the arrangement of electrons in that atom. Okay, therefore the modern periodic law may be stated as, again this modern periodic, after identifying or after coming to a conclusion that existence of different elements in chemistry, that is 118 elements in chemistry, is due to the electrons and their arrangement. So the Mosley thought of changing its periodic law. Okay, what he said is, he changed that is the physical and chemical properties of elements or periodic function to the periodic functions to the electronic configuration. So first, by the Mendeleev, arrangement was with the help of atomic weights. After that, after finding the atomic numbers, Mosley thought of arranging the elements based on the number of atomic numbers, 1 element, 2, 3, 4 and so on. Okay, but after thinking that the existence of different elements is not due to the protons, is due to the electrons and their arrangement, he himself modified that the periodic function, that is the properties, the physical and chemical properties of an elements are the periodic functions to electron configuration. This segment is changing. See, first one is based on the atomic weights, Mosley law of periodic law. Mendeleev periodic one, Mosley is changed to the atomic numbers. Then he himself is shifted to electron configuration. That is the number of electrons and the arrangement of the electrons is playing a key role. The number of electrons and the arrangement of electrons is playing a key role in order to have the existence of the arrangement of the elements in this modern periodic table. Okay, so that's what it is, the change in the periodic law. How this electron configuration, okay, how this modified modern periodic law, which is depending on the electron configuration, is helping us or was helped to H.J. Mosley to have the arrangement of electrons in the long form of modern periodic table, that we will see in the next session. I hope you understood what are these atomic weights and what are the periodic laws and how does this happen. how the next key concept, the actual sense of preparation of modern periodic table will start in next part, that is part 6. That in the next part that we will see how this electron configuration is helped, otherwise was helped H.J. Moseley to have the long form, the periodic table. These are the 3 laws, periodic laws you have to remember. You have simple, total and the properties of the elements are periodic functions to atomic weights. Was the periodic law of Mendeleev? According to atomic weights was the H.J. Moseley. He himself modified to the electron configuration. How this is helping? That we will see in the next session. Thank you. I hope you understood this session. Have a nice day.